All right, so we should be starting in just a minute here. Just trying to fiddle with a couple more parameters, let a couple more folks know that it's going to start. I'll be cleaning up this recording afterwards, and we'll actually be condensing it so that you can rewatch it later. There are a couple of stages that do actually take a little time, so we'll also condense those. Looking forward to having you guys here. I think this is going to be a pretty exciting little broadcast that we're going to do. Alrighty. Great. So welcome. Thanks to our first of hopefully a series of online live broadcasts and following then, of course, web recasts of this content. We really want to look at the process of deploying OpenStack. And in the past, I've done some little screencasts of sort of all-in-one, really simple deployments using the Kolla project. I wanted to get into a little bit more depth. I've got a couple of slides that I'm going to present here to sort of highlight how the pieces fit together and what we're actually going to do with it. And then we'll actually walk through some of the steps in a live fashion. Here we'll flip over to our screen. Migrate this in. Okay, so we have both a terminal session and I've also got some slides. So this is part of a class that we actually have. This is just sort of the introduction to the class. But in the greater scheme of things, the things that we want to really talk about today are understanding the requirements for deploying Kolla, building out the test system, sort of what does the infrastructure need to look like underneath the environment so that we can actually deploy this. We're going to use the Terraform tools as a way of creating automation around that. The Kolla process actually would normally use the OpenStack Bifrost project, but in this case, I want to use cloud services, cloud software, so I thought that something like Terraform was a more appropriate choice. And then we're going to look at the deployment of that multi-node Kolla environment. What we're not going to get into in this session is building out those images. We're going to use upstream images, but I will talk briefly about that process as well. Now, as I said, we're going to build out this infrastructure. It actually takes 5 to 10 minutes for us to actually build the resources because I'm using the packet.net actual hardware cloud. So I'm using real servers, but in a cloud sense. And so it still takes a little bit of time to actually build those systems. So before I get too deeply into things, what I'm actually going to do here is I'm going to launch the Terraform script. So if you haven't looked at Terraform before, we have a Terraform description here. All this code's available. I have a slide at the end of this deck that actually gives you a pointer to that, and I'll put that in the show notes as well. But basically, we're going to set up a couple of variables within Terraform. These are things that would describe how the different resources fit together. We're using DN Simple as our DNS service, so that way we have a dynamic way of actually configuring DNS. It's a pretty useful tool. A lot of these services can also be statically configured, but I really like to use DNS when I can, and DN Simple is a great simple way. I think it's $5 a month for a single domain, just so that you have a way of actually using DNS to talk to your services and devices. The second thing then, we actually need to define some devices, and so I'm using, again, packet.net is basically the hosting provider, service provider that provides physical servers on demand. In this case, I'm using them for this particular resource. And you can see that I have a bunch of information. I'm actually defining how my resources get configured, defining some bare metal resources, using the Ubuntu 16.04 release that they have available, my project ID, which it's not too useful without the token that goes with it, but that's you'd have to change this if you use these configs and tools for this. And then I have this provisioner. So this is a Terraform Terraform provisioner, which is going to help us create some initial Ansible code, specifically an Ansible inventory file against the nodes that we're creating. In this case, I have a fairly simplistic view of the world. I'm just creating a single controller and a single compute node, but these can easily be scaled up and down, and we'll talk about that in a moment as well. So the reason I wanted to go through this, we set up a bunch of resources, is because I just wanted to start the Terraform process. Now, the first thing that you do is you run Terraform plan, and assuming that your environment's set up right, plan will come back. You can actually store this and execute the plan. We're going to just use apply in a second here. But the plan comes back and says, okay, I'm going to create some DN simple records. I'm going to create some compute devices, a compute and a control device. These are the actual systems. And I'm also creating a couple volumes and mounting volumes. That's for an extension to this where we would actually start to play around with storage as well. In this case, we just have 2 machines. But again, this can very easily expand just by configuring one file slightly differently into a multi-node environment. All right, so we've gone through those basics. We now have these systems defined. I'm going to, like I said, we're going to apply our Terraform plan, and now it's going to go off, and this takes about 5 or 6 minutes to create these systems, attach the volumes, etc., update the DNS records, and now we have our systems environment. So while that goes off and does that, again, we wanted to build out our test system, so we're starting that. I'll talk a little bit more about what that test system looks like in a second, and then we're going to deploy Kolla on top of this. Now, when we talk about Kolla, Kolla is actually set up to support a broad set of the Openstack resources. Of course, the core services, things like our block storage with Cinder, Neutron for networking, of course, the Nova resources, Keystone Glance, and of course, also things like Swift for object storage, which actually is a little glitch here. I should fix this. That should be Swift. Fix it on the fly. So basically, we could actually deploy all of our key services, and Kolla supports deploying all those services. In addition, a number of additional resources, things that we would expect, things like Horizon are there, orchestration with Heat, support for the bare metal services with Ironic, etc. All these tools are all available as capabilities that that the Kolla project can actually manage the creation of the Docker images for, and also then help to deploy those images. So we know we're going to talk about specifically the core services today, and actually I'm not even going to deploy Swift in this particular instance, just because I'm not creating enough compute capacity or storage capacity really for that Swift deployment. But the same model applies if I were to add Swift or any of the other services that are supported. So when we talk about the Kolla project specifically, really we're talking about a project that looks to create Linux containers, specifically Docker image format Linux containers, around all of the services in the OpenStack deployment. It turns out that there are multiple ways of doing this, but Kolla is the one that seems to have gotten the most traction. It's the one that I have actually been using for direct customer deployments. Specifically, we're actually creating containers that have external configuration. So while the container is a static entity, something that you would just deploy and run, the configuration still needs to be live. It's still something that you're going to want to manipulate over time. And the current model for that in the Kolla environment is to actually have a configuration directory that sits outside of the container. So basically it's using an external volume mount to mount the configuration directory into that container. That way we still have the ability to manipulate the configuration without having to constantly rebuild our containers as we wanted to change that configuration, or creating a dynamic configuration where you would always have to update the container in order for the configuration to be consistent and valid. So that's something that the Kolla project helps us with. And in reality, especially as of the latest, the Okada release, 4.0 Kolla release, we really have 2 projects. One is the Kolla project itself, which really focuses on that sort of Dockerification, that containerization of the OpenStack resources. And the Kolla model, like I said, one piece is this concept of external configuration. So my configuration files sit as external volumes to my containers, so I'm going to map those in. The second piece is that the containerization is for each individual process. So you could also do something like the OpenStack Ansible project, which focuses on creating a single container for the Nova project or the Neutron project. In this case, we're going to create a container per process, effectively. So the Nova API has its own process, etc. All those pieces sort of fit together at that level. So as we're going through and building against this, we have the first part, which is Kolla, which would build images. We're actually going to cheat a little bit because we're going to use images that have already been built for us by the Kolla team and stored in the Docker Hub environment. But we'll talk more about that in just a second. The second thing is the Kolla Ansible project, and this is effectively how do you configure and get an OpenStack system running. Well, there's been a lot of work done in getting an Ansible-based OpenStack management environment put together, and actually the OpenStack Ansible project is another containerization model. It uses the LXC containerization model for actually deploying these resources. So there are multiple ways of actually accomplishing this task. We're using Kolla Ansible because it's tied to or maps very closely to how Kolla, the image model, has actually been built out. So we have those pieces fit together. And again, as a 4.0, they were split. And if you deploy an older version of Kolla, for example, if you want to deploy for Newton or even Kilo-based versions of OpenStack, you would actually probably end up getting just the Kolla project, which is both the Kolla image management sort of repository, and this is the Docker container image management components, and the Ansible code together. Those were split out as two separate projects in the Okada timeframe. So other projects that we have available to us as well, similar to the OpenStack or to the Kolla and Kolla Ansible components, is the OpenStack Ansible project. As I mentioned, this actually takes the concept of building out these systems images and has sort of a single image that's a little bit more monolithic, looking at the Nova resources as a whole. Also, the configuration maps a little closer to what most people are used to when coming from the virtual machine world, where these images are built and you configure the container image itself. So it has a little bit more of a state embedded in that container image versus the Kolla model, where we've externalized the configuration state of those resources. Just two different approaches to the same project. If you want to use Docker, or if Docker is the process that you'd like to containerize your infrastructure with, then the Kolla project is a better fit. If you want to use LXC, then the OpenStack Ansible project is a better fit. Both of them have good support, and a number of folks are actually using both projects. So it's not like one wins out over the other. It's just two different ways of approaching things. But again, I focused mostly on Kolla. It was a model that seemed to work well for me when I started in on the containerization of OpenStack deployments. The other project, which fits a little bit more closely to the Kolla project, is this concept of actually running those containers not just as standalone Docker processes or standalone LXC processes, but actually wrapping something like Kubernetes around those resources. So actually using a Kubernetes model to manage the deployment of those different containers. Now, you still have to configure them, so you still sort of need this Ansible layer as well, but the actual launching of and life cycle of the individual containers might be better handled by something like a Kubernetes resource. So again, not something that we're looking at specifically in this particular session, and something we might look at in the future. And there we would be looking at something like Kolla Kubernetes or the OpenStack Helm project, two projects that are looking at how to take a set of images and actually then deploy them within that Kubernetes systems environment. So other things that you might actually find that you would run into. Now, in our particular environment, the thing that we're actually going to build out, we're building something that's based on sort of a little reference model that I usually talk about when I talk about OpenStack in general. And that is, I have a control node that runs a number of key resources, and I have a compute node. And the compute node actually provides just the basic compute resources, so the ability to run virtual machine images. This is still an OpenStack system with VMs as the target. It has a Cinder agent running against it, so there's actually Cinder-backed storage available, and a Neutron load balancer, that's actually Linux Bridge Neutron environment that sits on the compute node. There's then a VXLAN connection between that and the control node, which runs an actual equivalent system. It actually also acts as a compute target resource. So it runs the Neutron agents and the Cinder agents, Nova compute agents as well, but it also runs all of the control functions and all the database resources. So the control node is usually a little bit beefier system than the compute nodes in the model that I would usually use. And so this is our reference, and you can see that there are a number of networks sort of defined. In this particular model, in the packet.NET environment, I don't really have the public sort of floating or public external network. I have one network and one IP address that I allocate against the system, and we share for things like the Horizon user interface. But the actual floating IP external network interface within the OpenStack environment, we're just overloading an internal interface for that function. So it's not quite the most expanded environment, but that's just because of the resources that I had available in order to run and build the system. You can still actually use floating IPs. The entire system works. You can actually log into systems. The only trick is that you have to connect yourself to the control node in order to get access to that resource. So that's sort of an embedded set of networks rather than external ones. There is a VXLAN connection that does get created between the different nodes, so we do actually have the normal networking resources running. It's just that we don't really have that external network model in this particular deployment. But usually you would have that, and actually configuring the Kolla resources to enable that is a very straightforward process. So for our base OS, one of the additional things we have to realize is that it's not enough to just have the OS. We actually need a couple of key tools on that operating system in order to even consider running Ansible, or sorry, running Kolla, because Kolla relies on Ansible, Ansible relies on Python, and actually to get all those pieces up and running, we need things like Python and the pip tools. We also use, in our case, we're using pip to install the Kolla project rather than pulling it from Git. Couple of different approaches there. We need Ansible, and usually that's the latest version of Ansible, so we're using Ansible 2.2 in this particular case. Python and Python pip, and we actually update pip to the latest, although that doesn't really seem to matter so much. It just complains if you don't. We also need GCC compiler and a couple of libraries, and this is specifically to make Ansible install properly. But once we have all those components on the base OS, then we can actually go and get our system started. The other key resource that we need is we need Docker. And in this case, there are a number of versions of Docker available. There's a 1.13 available now, but I've found that that doesn't work very well, at least not for our particular case, the way the system has been designed. So we're still using the 1.12 versions of Docker, actually 1.12.6 I think is what we're currently using. And that's what we're going to actually configure with our systems environment. And then the last thing that you need, this is really more of an Ansible requirement than it is a systems requirement, but in order to run Ansible, I need passwordless SSH between the nodes. So the control node, which is where we're actually going to launch our Kolla resources and our Kolla deployment, needs to be able to log into all of our compute nodes and any other resource nodes that we might build via passwordless SSH. Now, as long as I have a way of doing that, even one user's way of doing that, I have a number of ways that I can extend that process. Now, before we actually deploy Kolla, we have to realize that we need images for this to happen. So we need some images to actually deploy the Kolla resources. So if we're going to build that, the number one thing that we have to do is we actually have to get the images into some form of repository. And there are two options there. We can either create images and deploy them into a public repository, Docker Hub, the CoreOS-Key.io service, or even our own registry that we just happen to put onto the public internet. If we do our own registry, the one thing we have to be aware of is either we're going to end up with an unsecured registry because we're not going to set up TLS certificates, or we can actually configure TLS, and then either we have to share those certificates if we build our own self-signed certificate authority, or we could do something like Let's Encrypt and use Let's Encrypt to deploy that registry and then deploy our images into that registry. As I said, we're not going to be doing that in this particular class because that would add yet another couple of hours to this entire session, but I just wanted to at least bring up the fact that you could actually build your own images. Now, it turns out that there are already images built that are available in the Docker Hub environment, the hub.docker.com environment, that we can actually leverage. And so we're going to be leveraging those. Those are Akata-based images that are available to us. And so we're going to pull from that particular set of resources, which means that since Docker by default is set up for that registry, we don't actually have to do anything. We don't have to configure anything additional. But there are instructions for manipulating either your own private registry with or without TLS. I have found that when I was trying to do this, I basically had to create my own self-signed certificates and configure all my nodes to be able to read from those certificates so that Docker could read from them. There was a whole bunch of additional code that I wrote at one point specifically to do that, but I think that's all been cleaned up at this point. So we do actually have support for basically every operating system that one might want to be running these containers or the base container images from, be it a Debian, like a Ubuntu environment, or a CentOS, or even a Red Hat Enterprise Linux or Red Hat OSP sort of environment. whether those repositories for the resources are using the source repositories, so upstream Git, or potentially the repositories are actually our local resources. We have the ability to sort of work through and manipulate basically all of those. So all of that's available, but again, we're going to be using the Okata upstream models. So with all of that, I think we're basically at a point now where we can start thinking about the multi-node deployment. Now, when we actually go through the process of doing this, once our systems are built, we have to do a couple of things. We have to do our pre-install of the basic resources like Ansible and stuff of that nature, and then we can actually go and configure our multi-node inventory file. Now, if you were here at the beginning, I was talking about Terraform and Terraform deploying this thing, and Terraform also having its own embedded provisioner, which creates an inventory file for us. That's an inventory file for us on our local machine, in this case a laptop, talking to the cloud, which is where our resources are, our compute and control resources are going to live. That particular connection is for us to actually connect, and that inventory is for us to have our local Ansible service talk to those particular machines to get things started. The next inventory file we need is what are our resources supposed to be doing in terms of OpenStack. And so this is where effectively Kolla's version of Ansible, which is Kolla's wrapper around launching Ansible, where that particular setup exists, and what resources are supposed to be mapped. By default, we basically need to tell the system about 5 different resource domains. Our control resources, and that could be 1 to n number of control machines. Usually you define 3, and the system will actually set up a 3-way HA control plane for us. Our compute systems, so that we actually have our compute resources, and those are usually separate. These can be overlapping. These are Ansible groups, so we can actually describe overlapping resources, and actually our template, my default, does, because I map control and compute onto the same nodes. So compute becomes a control node and on a compute node. The network services, so these are the services, basically the control services, not just the network agent. Our monitoring systems, if we want to actually enable monitoring, even so far as establishing a separate elk stack just for this environment. And then storage, whether that be Cinder storage or Swift-based storage services, all of those things can be defined. And then all of the individual projects that Kolla knows how to deploy can also have their own groups. They get pulled back into things like most of the resources will end up on the control servers, but I could actually break out separate database servers or monitoring servers, or if I was doing something special with networking, I could break those out into separate server environments as well. So all of those things are possible, and they're all defined by the multi-node inventory file, basically just having all of the different groups defined. Now, I will say that for each release of Kolla, it's important to make sure that you're actually getting the right version of that multi-node description file, because there is a little bit of fragility in the Ansible code that I've seen if you don't have the right groups defined. So if it's looking for a group that it expects to see and doesn't find, that has, for me, broken Kolla in the past. So just be aware of that when you're looking at developing your own multi-node file to describe things. That might have to be updated as you update and upgrade. So we're almost there, guys. We're almost at a point where we can actually go and launch all this code and get our Kolla environment up and running. So what we're going to do, set up the baseline OS. So we're going to get the OS installed. We already kicked off Terraform in our particular case to get that launch started. We're going to install the required tools and underlying components, and then we're going to get the Kolla tools installed on the machine. The second step from that is that we're going to actually want to configure and install Docker. We need to ensure that it has the right configuration. Specifically, there's a shared mounts parameter that has to exist. If we're using an insecure registry, we would have to go in and actually set up the insecure registry resources as well. We're not going to have to do that, thankfully. And then we're going to set up the files that actually describe the OpenStack services, the resources that we want and how we want them configured. We're going to do that through 2 files. One is a file for passwords that describes passwords and tokens and other interaction resources that we need for the system, and also a globals directory. So the globals file sort of describes a number of on-off switches for resources. So what OpenStack services do we want to have deployed, and also we want to look at what capabilities do we want to extend, specifically things like network and storage resources that we want to map into this environment. For the password side of things, we do want to define unique passwords for all of the different services to interact. And it turns out there's a tool, Kolla Gen Password, that was set up specifically to go and create a password file for all the services that the Kolla system knows about. It will generate random passwords for you for everything, including your admin user. I usually go in and change the admin user to something I know, but this is sort of what we actually get out of this. And then lastly, we need to set up our multi-node inventory file for this particular environment. Again, I have a template that actually launches this for us, so that simplifies the process a little bit, but you can also do this by hand. Now, at this point, if we've gone through all those steps, we should basically be ready to go. We will do one other thing. We'll run the pre-checks resource. So there's an Ansible playbook that actually goes through and makes sure that all the configurations look right, that there isn't a parameter that's missing, or that the Ansible code would expect to see that it doesn't see. And so it does that by actually doing a validation step on each of these different processes. So it's actually a pretty powerful tool to make sure that you have your configuration right, rather than getting into the deployment and finding that we're missing a parameter somewhere. And then lastly, we get to go and launch the deployment. So a very straightforward, very quick way to launch the system. Before we get into that, I do want to bring up that apparently I forgot to drop in. I do want to drop in another link to a page. I'll find that here in a second, where we actually have a class that extends this basic knowledge into much more depth, and so we'll talk about building images and all that kind of fun stuff. I will get the link for you. I can even spell available right, and throw that in here in just a second. And as you can see, there are a lot of moving pieces in this. The interesting thing is that once we actually have some code to try to wrangle this into a more manageable state, there's very little that you actually have to do. So I've already run one task, for example, the Terraform task to go build my systems. And what that has done, if we actually we can just sort of see that it's gone through, and it was really sorry if the audio in the live broadcast is and basically install a bunch of services and in our case, we don't need services and we'll go through and make sure that services exist, that the system is able to do what it needs to do, that apt is configured appropriately, etc., and make sure the firewall services are where they need to be so that systems can talk to each other. Make sure that all the systems resources are installed, make sure that Docker is installed. This is, like I said, the sort of the heavy lifting that it has to do. Because all of these systems are now ready, we should now be able to do something like Kolla, Ansible, multi-node. We could do our pre-checks. As I said, this is something that, if you know the environment is correct, so we just bootstrapped the machines and we built all the pieces into it, this shouldn't be necessary. But if you actually do run into a problem, sometimes it's better to run the pre-checks command to see if it can tell you what might have been the cause of the problem, rather than trying to debug directly from the deploy output. Both ways are reasonable approaches, but in this case, we're just looking at the pre-check information as a way to get that key data out of the system. All right, pre-checks also came back and said, hey, everything I checked looks fine. So now we can do the big reveal. Kolla Ansible inventory. We want our multi-node inventory. And we're going to do our deploy. And so now it's going through and actually starting to deploy things. This might actually take just a little while because it does actually have to pull the images down from Docker Hub. But the nice thing is that once it pulls down one of the key base images, because of the layered file system approach and the containerization of basically the Docker container model, once I have one of these images, which are fairly large, they're about 700 or 800 megabytes a piece, once I have one of them, I have most of the code that the rest of them share. So then I'm just pulling down the individual unique layers for each particular container. So the system becomes much more efficient pretty quickly. And this entire deployment will take potentially on the order of 10 or 15 minutes. There is a toolbox container. You can see it's launching that. That's a container that actually gets used by Kolla to run a number of additional services and resources. So now we're running sort of the one task that I have seen the system fail on more often than just about any other, which is actually making sure that the MariaDB container is up and running. This usually takes a minute as it's actually doing some additional migration of the database container as well, so that our databases get configured appropriately. And here it's checking to see if the database actually started. And sure enough, it did. The other area where I've run into problems is with Rabbit. Rabbit not starting, but more often than not, the Rabbit not starting is exclusively because of a host name mismatch. Either host names weren't defined right, they don't exist in DNS, they're not in the etc hosts file, etc. As long as you have your etc hosts or DNS working right, I've seen Rabbit successfully launch in this particular environment as well. And as I said, some of these stages will take a little bit of time, but shortly here we'll have a running OpenStack system that we can work with. So for those of you that are still online, there is a live chat section. I think some of you have found it and posted some comments. If you have any comments or questions, feel free to drop them in there. And at least while we're running through this section, I'm happy to answer any questions that folks might have. This is all super exciting. Once it starts running, there's really not much to do other than just sort of watch it go through and do its individual processes. You can see it's pulling information from our globals file. And actually, while this is doing this, I'm going to launch another terminal session here. I'll just have another session here on top. So we can log into our control. What we can do is we can look at, so in the Kolla directory, we have, as I mentioned earlier, we have some global definitions, and we also have some, we also have our passwords. The passwords file, this is only useful when you're actually trying to understand how the different resources come together. But these passwords get generated. You can either do this all manually or you can use the gen passwords script. So these are the database and Keystone. So Keystone is the Keystone user, the AODH user in Keystone's password. AODH database is the database access password for these particular resources, assuming that these databases or services actually exist. So there's more actually built into this passwords file than what you might actually be deploying at any one point in time. And in this case, there's also SSH keys that get generated for a number of the different resources where SSH would become an important task. So that's the passwords file. But maybe the more important one is the globals file. This is the file that describes the specific resources that we want to manipulate. Now, in this case, I have created a very simplistic one. I haven't used the example. I've just overwritten the example with my own specific resources. And all I'm configuring in this particular globals file is the IP address for the virtual IP, basically the management IP that's going to be used for this environment, the network interface that's going to be associated with, a separate network interface that's going to be used for the external resources within the system's environment, and then a couple of resources. So there's actually a much larger list of resources available. In this case, I've turned off the HA proxy configuration that gets created so that you can actually have a virtual IP, so a single IP address manipulating a multi-node controller environment. I've turned that off in this particular instance. I could also turn that on, actually remove these two lines, the enable HA proxy and enable keep live D, remove those two lines, and by default those systems will automatically start. But I can also turn on or off a whole additional set of resources and parameterize those resources as well. By default, user local share, Kolla, let's see, we want Ansible. The default globals file, so this is the example default globals file. We can see that there's a lot more information in here. How do I want to configure things? When do I want to run them? What version am I supposed to be using? Et cetera, et cetera, et cetera. Here's the one parameter that I actually manually configured. Right, we have Docker registry information if we're going to use our own private registry, and then there's the whole list of resources that I might want to turn on or off defined here. And you can see that on top of that, things like saying, yes, I want to enable Horizon. Well, here, the fact that it's commented out and is defined as yes, the default is yes, I'm going to turn Horizon on. The default is that I'm going to turn on heat, but I'm not going to enable Grafana, for example, or Gnocchi in this particular instance. I might also want specific Horizon resources to be enabled, and so I can actually describe those as well here. Right? And so this is, again, this is the template that you can use to enable certain things. I will also highlight one other thing, and that is, again, one of the things that we'll be talking about in the class, which is that there are services like load balancing as a service or firewall as a service. Well, these are resources that are plugins. The default images do not have these plugins installed in them. And so in order to actually enable one of these plugins, it's not enough to just say, yes, I would like Neutron load balancing as a service. I actually also have to update my Neutron server Docker images specifically to support that load balancing as a service function. So just something to be aware of, that while these are, they look like on-off switches, they're not exactly 100% on-off switches, because you might have some specific plugin capabilities that you have to implement as well. Anyway, so we can go and configure a bunch of these things. As you can see, I used a very simple one, but it turns out that that was enough. Now, as I pointed out in when we walked through the initialize script and the stuff that I commented out, one of the things I commented out was running this post install script. This is going to run things like add flavor and import image and set up network scripts, just so that we've actually established some key resources within our OpenStack environment, so that we actually have a usable system rather than just a functioning OpenStack environment. So in this case, I'm creating an image, creating a bunch of flavors for me to use. I'm creating a set of network resources, including routers. So all of this gets done automatically and allows us to set up a system. We also created a bunch of default security group rules so that we actually have normal access to things. And you can see, hey, here at the very end, if we go to this node, which also turns out to be our control instance, here I can actually pop up a little image. Nice lion. We have control cloud sushi.io. And we have our login screen, and now we have Horizon working. And if you were fast enough, you saw what my default password is, super secret password for this. And we should log in and have a running system with some resources. Always seems to take a minute for the first time. Sure. And we can see that there's currently nothing defined in our environment, but we can see that we have images installed. Here's our service image. We can see that in our network we have a basic topology with a router and a public network. All right, so our public and private networks exist. Right, so our OpenStack system functions as we would expect it to. We can also, if we go back to our terminal here, we can also, the setup script also creates an OpenRC file. We could pull that down from Horizon, or in this case, we just created one. And then, we can, actually, we have to source that first. So source our OpenRC, and now we can do a Nova list, glance list, image list. Or OpenStack, let's see. Right, so we have a number of different ways of actually interacting with the system, and now we have a multi-node system. Actually, we could do Nova Hyper. We can see that we have our two hypervisor systems running, control and compute. And with that, we have a running system. This is now a complete environment. One of the best things about this, though, is that it's also a cloud system, which means that if I want to, I can do Terraform destroy, and boom, clean up my entire environment. But that was a basic environment. All the services and systems were running. If I need to rebuild this now, I can use basically my initialize script to do an all-in-one install or a multi-node install. If I update my inventory to have more machines in it, I can actually have a multi-node controller deployed. I can have multiple compute nodes deployed. I can create multiple storage nodes and map them into the system as well. That code, as I mentioned, is available. So the Cumulus Tech Kolla multi-node scripts, these are my tools for initializing Kolla. Kolla then is another project on top of that. You can pull that down from Git as well. OpenStack Kolla code is there. And as I mentioned, we are looking at building out a class based on this. And let me see, I meant to put this link in here. Let's see if I avoid creating too much back channel. Anyway, so this link will also hopefully give, if folks are interested, you can pop on over there and sign up. We're just collecting people's interest in actually having this course put together, but We have an agenda listed, and within a month, I think we could actually turn this on if we get enough interest in doing a deeper dive course in Kolla, using the tools and how they interact. But hopefully this was useful for folks. Again, please, if you have questions, drop them in on the chat. If not, then thanks for watching, and we'll look at doing something else soon. If you have any thoughts on what you'd like to see me talk about next, you can drop that into the chat as well. But if not, then thanks so much for joining, and we look forward to talking to you again next time.